711, question 9. Find the area enclosed between the curve y equals to x cubed and the x-axis and the line y equals to minus 3x plus 4. Now, what would be your first step when doing this question? What would be the first?
I would draw them up and then see which one's higher.
Yeah, that's right. So you draw it, right?
Yeah.
Okay, cool. So have you graphed or have you drawn this?
I tried to, but I don't know. I kept getting the wrong answer.
Okay, well, let's have a look. You got y equals to x cubed. Which kind of looks like this, yeah?
Yeah.
The x-axis, which is this wonky thing here, and the line y equals to minus 3x plus 4. Now, what would that look like? Describe to me the features of this.
Y-intercept at 4.
Yep.
And then it'll be like negative gradient kind of thing, slope down.
Yep, so this way or this way?
That way.
Yep, cool. So -3, it's kind of going to look like that, yeah?
Yeah.
Cool. So which region is going to be represented by the area that we're looking at?
Would you minus the top one? Minus the straight line.
Okay, well, let's have a look, right? We want the area enclosed between y equals to x cubed. So this area here, yep. The x-axis, which is this area here, yep.
Yeah.
Okay, and then we also want the area enclosed by this line. Have you seen it yet?
The little part down the middle?
Yes. Are you referring to this bit here?
Yeah.
Yeah, that's the bit. How would you go about finding that bit?
Would you find the x-intercepts of the straight line? To get that?
Yes, the x-intercepts. So let's have a look at what points we need to find, right? So we need to find this here. Yep. We also need to find that point there. Yep. How might we find that point there? Can you, are you able to work out and tell me what that point there is?
Yeah, when y.
What we do, what's this point here? This one should be obvious.
0.
Yeah, so that's the origin. Yep.
Yeah.
Yep. Okay, can you find that point there for me?
4 on 3.
So y equals, so you make y equal to 0. Yes, 4 on 3. Good. So that's going to be 4 on 3, 0.
Yeah.
And then, okay, you've actually done a lot of the hard part. Oh, there's only one other hard part to go. What else would we need to do to work out this area?
Minus them or something. -1 from the other.
Not quite. This one's a really interesting example.
Yeah, because normally like you minus
area.
the higher one by the lower and all that.
Yep. This one's kind of a little bit different. There we go. Okay, what you would do is you would actually then find this point here. Okay?
Yeah.
Do you think you can find that point?
When they equal each other?
Yep. So you'd solve it by simultaneous equations, right?
Yeah.
So what would that be? So it'd be x cubed equals to, is it minus 3x?
Plus 4. Yeah.
Yep. So let's work that out algebraically. Okay, so it's x cubed plus 3x minus 4 equals to 0. Yep. And then, so if that was equal to, say, p of x, okay, and you've done the unit on polynomials?
Yeah, I think so.
Yeah, what can we test here? What would be a good number that we could test? P of?
1.
Yeah. One's an obvious one. Cubed plus 3 times 1 minus 4 equals 2. What does that equal to?
4, 0.
0. Yep, good. Okay, so bingo, we've solved it. So x equals to?
1.
1. Yep. And y would equal to?
Well, 1.
1 as well. So what's this point here?
1, 1.
1, 1. Okay, good. All right, now why did we find that point? Any ideas what we might do?
You do the area under x cubed to that point and then add the other one.
And then, yeah, what do you mean add the other one?
And then add the area of the other one from 1 to
4 on 3?
1, 3, yeah.
Yes. Absolutely brilliant. Good. Okay, so do you see how this one's different from an area between two curves question?
Yeah.
Yeah. So with the area between two curves, we're finding so if you've got a situation where you've got a top curve and a bottom curve, the top curve is f of x and the bottom curve is g of x. Oh, it's the other way around, isn't it? G of x is the top curve and f of x is the bottom curve, right? Then the area between them is going to be g of x, the top curve, minus the bottom curve,
Yeah.
dx, right, between, say, A and B. Yep.
Yeah.
That's the area. That's a typical area between two curves question. That's not what we have here. Okay. What we have here is two areas that are side by side. Got it?
Yeah.
We've got area A, and we've also got area B. Does that make sense?
Yeah.
And to find area A, what would we do? Talk me through it.
The integral
Yep.
between 1 and 0.
Yep.
And that's of x cubed.
Yep.
And then dx. And then,
Yep.
so then you would integrate that.
Yeah. Yeah, we'll make do it.
The power of 4 on 4. And
Yep.
then 1 and 0 in the brackets near it.
Yep.
And then that equals a quarter.
Yep. A quarter minus 0 is just a quarter, right? I'll just put full working out, which is what we should be doing. Okay, cool. And that's area A.
Yeah.
What about area B?
So between 4 on 3 and 1. And then negative 3x plus 4.
dx?
And it would be negative 3x squared on 2 plus 4x.
Whoops. Okay, and that's between 4 on 3 and 1.
Yeah.
Okay, cool. Now, is there an easier way of doing this?
Oh yeah, right. A half at the front.
Base times height. Because this is a
Oh.
right angle triangle. Yeah,
Okay.
yeah. So it's half times, now the height is going to be 1 and the base is going to be 4 on 3 minus 3 on 3. 1 on 3?
Yeah.
Yep. So half of 1 of times 1/3 is 1/6. Does that make sense?
Yeah.
Okay. So that the total area is going to be equal to, what's it going to be?
5 on.
Plus 1 on 6. Which is going to be, so 12, 5 on 12. Did you say?
Yeah.
Yeah. Cool.
Okay, cool.
Got it?
Yeah.
Yeah. So this is just a triangle. So we just use the area of a triangle. Yeah.
And with the, you know how they have like some of them have the absolute value signs? Like I'm not sure when to use them. Is that just when it's under?
Yeah. Good question. Good question. All right. Now, let's do this. Do you know the difference between area and integral?
Not really.
Okay. Let me show you, right? And hopefully if I go through this, this will clear up any confusion for good, right? Because this is the sort of question that they'll ask you all the time. Okay. All right. So if we want to find the area between a curve and the x-axis, say the curve looks like that. Okay. The area will be positive and positive. Does that make sense? So
Yeah.
if the area is below the x-axis, it'll still be positive because area can't be negative. Got it?
Yeah.
If we're looking at the integral says that this area is positive, but this area is negative. Does that make sense?
Yeah.
Okay. So now let me ask you this, right? That's A. That's B. Got it? What is the area? What is the total area of this shape?
A plus B.
A plus B. Got it?
Yeah.
Would be the total integral of this shape.
A minus B.
Yeah. Okay. Would be A minus B. Okay. Now, if this was a sine graph, or, okay, well, it doesn't have to be a sine graph, but if this was a graph where the area above was equal to the area below, right? What would the integral be?
0.
Yeah. What would the area be?
Or 2A.
Do lots of that. Does that make sense? And so oftentimes you need to read the question carefully to see whether they're asking you to find the area or the integral.
Yeah.
Okay? If they're asking you for the integral, they're asking you just to find the overall net result. Okay? But if they're asking you for the area, then there are some special situations that you need to consider. let me just do this. All right. So let me share with you what I mean. Okay. So you have a curve that looks like this. Imagine you do. Imagine you have a curve that looks like that. And you have to work out, the question says, from zero to P, right? You've got to work out the area from 0 to P, okay? Or the question says, work out the integral from 0 to P, okay? And the curve itself is just f of x. Got it?
Yeah.
Let's start with the integral first. When you're integrating, your integral will already take into consideration that this is going to be positive, this is going to be negative, and this bit's going to be positive. Whoops. Does that make sense?
Yeah.
So it'll already factor that into it. So the integral can just be written like this. Whoops. And that'll just give you the overall integral. Does that make sense?
Yeah.
All right. But if we were to find the area, okay, then this bit here, we actually have to find the absolute value for when we're finding the area.
Yeah, okay.
Got it? All right. So let's make that A and let's make that B. That point there and that point there. Okay. What would then this look like? All right. How would finding the area between A and P or O and P look like? It would look like this. It would be the integral between 0 and A of f of x, okay, plus this bit here we know is going to be negative. So to find the area, we have to find the absolute value of that negative bit. Got it?
Yeah.
And then this bit here is going to be positive. All right. So it's going to be the integral from B to P f of x dx. Does that make sense?
Yeah, that does.
Yeah, yeah.
Okay.
So is that clear now what the difference is between area and integral?
Yeah.
Yeah. So you just need to read the question carefully. And I would suggest that when you do questions like this, underline the word either area or the word integral. What are they asking for? Okay. And that way that'll help you to determine whether you use this approach where you have to split things up and find the absolute value of any negative bits, or whether you just integrate. Okay.
Okay. So if they ask for like the area, I'd have to kind of draw it to make sure there's no negative.
Absolutely. Yeah, yeah. If they're asking for the area, you can't go wrong. Well, you can go wrong, but you know, you're going to be much better off if you graph it.
Okay.
Okay.